Hello and welcome to part 6 of Dev Maths and Stats Refresher Course, Lecture 8. In this video we're going to finish off this demonstration here by adding in a new random variable, z. So it's similar to what we did in the previous demonstration. So here we're going to have z. Oops. So there's my values of z, and I need 3 parameters of this. 3 parameters for this. So z is going to be given by A, B and C. I'll start with it as 1, 0, 0 for now. Make it look a bit neater by just leveling up a bit. So the idea is that z is going to depend on x and y. So it's going to be that. I'll just fix that times x times this value plus this one times this one plus just a fixed constant. Oops. So that's okay. So if I copy that down to the end of the road, actually there, a really interesting mess. Okay, didn't fix the constant. Let's work out why only every other value went wrong. It's better than that. At the moment, that should be the same as x. Yeah. Also be good to refix the panes there. So we don't keep zipping up and down. And not there, but there. So we can actually see the 3. That's better. And this, I don't think that's so interesting at the moment. Okay, so z depends on x and y. If I put that 1, if I put like this, then it would just be the same as y. So it's no x plus y. If I put that, then z is now x plus y, and so on. That would be 6x, z is equal to 6x plus y. Let's maybe just have it as that for now, so we know that z next is the same thing, because that lets us check the rest of the answers. Because we need to, as well as that, we need to work out z and cov xz. By putting in requisite columns. So again, pause. How would you do it if you know how to work out var z and cov xz? Okay, so pause and see what you do. Okay, so what I'm going to do is put the ZP column in, because I need to work out the expected value of Z. I can use the P values from over here because it's the same probability values. So that can be summed down to the bottom. So that is so I didn't actually I've just got the probabilities of Z. Actually times it by Z. Okay, so that's expected value of z. So expected value of z, then you need the variance of z. So for that you need z minus z expected value of z, the power of 2 times probability. So it's z minus this thing down here fixed, the power of 2 times probability. And then you should be able to check these two results. So this should be the var of so that's pretty shocking. This should be these two things here, expected value of z and the var of z, should be equal to expected value and bar of x. So that's right. That's absurdly wrong. So something nasty happened on the way to the forum with this one. No, it's the same old thing. Didn't fix that. No, I have fixed that. Okay, what happened here was that I've used this. This is, I was thinking that was a probability. Probability is over here. Sure, using that one. It's a bit better. Yeah, so this refers to probability back in column D. That's better. (67707). So this time, hopefully, we sum it. That should now be the same as the variance of z. Okay, that's good. So we've got the expected value of z and the variance of z. And then we need the covariance of x and z. So there's one more column to put in here, which is to get the covariance. That's all we're doing. X minus how far x is from its own mean times how far z is from its own mean. All to the power of 2, not to the power of 2, times probability. So the difference of each one from its mean times probability, so we translate that into formula. Let's try and get this right this time. So it's z, I'm going to do x first to make it the same as the one above, equals x, which is going over there, over here, minus the mean of z, mean of x, which is down here somewhere, of x, times, it's time for z, something is, minus the mean of z, zebedee, be a minus sign, times probability. D. here we have cov of x and z. Now, one thing you might notice is that at the moment cov of x, z is the same as var of z. And that's because the way I've got it set up here, which I thought was frozen these panes, there we go. Oh yes, that's, yeah. Frozen up. Anyway, the way it's set up, z is actually equal to x. So the way this is set up here with these parameters. So if z is equal to x, then the covariance of x and z is the same as the variance of x. So covariance of x with x is the same as variance of x. Okay, so now we've got everything set up as it should be. So we're just going to experiment with changing A, B and C and see how those things change. So we really need to get a better view than this. We can't. Yeah, we need to unfreeze the veins. Come down and freeze them here. Okay, so now we can keep our beady eyes on these things at the bottom as we change these parameters. We might have to, talking of beady eyes, strain your eyes a bit because it's better to be able to see a bit more of what's going on over here. That's just about right there, so we can see everything now. So, what happens? So the idea now is on the sheets you've got everything you need except for, okay, we haven't got that, do that later. We've got everything we need here to do all these things down to here, variance of x plus y and so on. So by playing with A, B and C, you should be able to fill in these rules now by observing what happens. So please go ahead and try to do that, and I will do it slowly. Well, you can pause slow. So please pause, have a go. So I hope you've had a go at that, and I want to look how the variance of z compares to these. And what I want to make sure is that to start with, z is going to be x plus y. So to do that, if I put 1, 1, then over here you've got, this is var of x plus y. So how does var of x plus y compare with var of x and var of y? What you'd want is, you'd hope that it will be equal to this plus this, but it isn't, okay, which is a bit odd. But to give you a clue on what's going on, you can again just take that whole lot of extra work we've done here, L11, go to the next thing, paste it into L11. Make a copy. That's a bit better. I still missed again. take that, paste it to L11, see if that works best this time. So that's pasted better. So here we got the same thing set up. So a new variable z, and I set it so that z is equal to x plus y. So z is equal to x plus y because of where I've set a and b. So if I come down now and look at the variance of z, so this is the variance of x plus y, in this case it actually is equal to variance of x plus variance of y. It does give you the variance of x plus y. So why is it that that's correct there but this one is not correct? And it's clearly because these are independent. So for independent variables, this does work out. Var x plus var y equals var z. And what's the other side about independence? Well, it's the covariance being 0. So in actual fact, it comes down to, because this is 0 here, it's y that plus that equals that. So in the one where they are not independent, you just have to find a way of adjusting it with the covariance. And the way you actually do it is take the variance of x, take the variance of y, and add on to that, weirdly, 2 times the covariance of xy, then suddenly you're in business. Yeah. So, at long last, we've got something we can add to this formula sheet, variance of x plus y. Long neglected whiteboard, we can come back here and say that variance of x plus y is equal to variance of x plus variance of y. That's what you'd expect. For independent variables, that's it, end of. But for the general case, when usually things are not independent, covariance x, y, I missed out an important figure. Wonderful, figure 2. So variance of x plus the variance of y plus 2 times the covariance of xy. So that's that one. Now, to work out this one, we're going to have to start multiplying things by numbers. So it's so many x plus so many y. And we can start by doing the one that's indicated there, where you have a minus 1. So a is 1, b is minus 1. What happens then to the variances? Well, in that case, you'd want, when you're subtracting them, it does something slightly different. It isn't variance of x minus variance of y. It's, you might think it'd be that minus that. That puts you on completely the wrong track. If you think about it, first you need to notice that variance of x, variance of minus x, is not minus variance of x. So you can see that if we put up here 0, minus 1, remember what that gives you. The variance of x here is unchanged. So variance of minus x is the same as variance of x because variance of minus 1 times x is equal to minus 1 squared times variance of x, which is 1. So when you're adding two things together, well, so when you're subtracting in this case, 1 minus 1, when you're subtracting them, you still need to add the variances together. Oops. But if you think about what happens to the covariance when you subtract something, if you flip one of the variables around, what's going to happen to the covariance? Well, the covariance is telling you that when one gets big, the other one gets bigger. So if you flip them round, then when one gets big, the other gets smaller, so the variance becomes negative. So it's the same formula, it's times 2. Subtract 2 times those. So cov A minus B, or cov x minus y, is equal to variance of x plus variance of y minus 2 times the variance of x, covariance of xy. More generally, the one I want on the sheet is just A times it. So if I double them, what would that give you? Well, we know that's trying to get at this formula here. We know that multiply by 2 will multiply the variance by 4. This will multiply the variance by 9. So what you're going to need here is 4 times the variance of that plus 9 times the variance of this, and then plus, well, it's 2 times 2 times 2 times 3 times the covariance. So the formula here is a squared bar x. So that's like this one. And the same for b, b squared bar y. But then you get this 2 factor, but it's 2 times a times b times cov x, y. Okay. What happens to cov when you change a and b? So covariance of x plus y, and covariance of x and minus y, and covariance of x and ay. Okay, so I think the video is going a bit long, so at this point I hope you've got this set up. You can experiment with A, B and C, see if you can get these rules together, and then if you want, make a start on the next part, and then I'll finish that off in the next video. So thanks for watching.